Okay, so today we are diving headfirst into the bizarre, the counterintuitive, and the just plain fascinating world of quantum mechanics. We're going to look at the actual experiments that seem to completely rewrite the rules of reality itself.
You know, this line from our source material really just says it all, doesn't it? We think we've got a solid grip on how the universe works, but then you zoom way, way down to the smallest scales, and all the rules we take for granted just get tossed right out the window. So, before we even get to the wild experiments, we kind of have to recalibrate our brains. Let's start by looking at this huge gap between how we think the world works and how it actually works down at the quantum level.
So look at this. On the left, that's our everyday world, right? A baseball is a solid thing, it's in one spot at a time, and when you throw it, it follows a path you can predict. But over on the right, that's the quantum reality. A particle isn't some tiny ball, it's more like a smear of possibilities, a wave of probability. It can literally be in many places at once, and its path isn't even real until we look at it. I mean, how wild is that? Okay, so that idea brings us to probably the most famous, most foundational experiment in all of quantum physics, the double-slit experiment. This is where the weirdness really kicks into high gear. Let's see how a single particle can somehow be in two places at the exact same time.
So this experiment slams us right into a core concept called wave-particle duality. And it's this idea that the basic building blocks of everything, well, they don't have a fixed identity. Sometimes they act like a solid little particle, like a tiny billiard ball, and other times they act like a wave spreading out across a pond. And the strangest part? It seems like our act of just looking at them is what decides which one it's going to be.
Okay, so follow this. We fire one single photon at a time. Now, logic would say it has to go through one slit or the other, right? And it should make two little bands on the screen behind it. But that is not what happens. The photon leaves the gun, it sort of becomes this wave of potential, goes through both slits at the same time, and then interferes with itself on the other side. This creates a pattern with lots of bands, a pattern that only a wave could possibly make.
And this is where it gets even more mind-bending. Scientists, of course, wanted to know which slit the photon really went through. So they put a tiny little detector by the slits to check. And the second they did that, the wave pattern just vanished. The photon suddenly acted like a normal, well-behaved particle and made just two bands on the screen. And that's the crucial point. The very act of observing it forced the universe to pick a side.
So let's level up the strangeness, because this just keeps building. If one particle acting weird isn't enough for you, what about two particles that are linked across the entire universe? This is what Einstein famously called spooky action at a distance.
We're talking about quantum entanglement. Okay, imagine you have two coins, and they're magically linked. You can separate them, send one to the other side of the galaxy, but the instant you look at yours and see that it's heads, you know with absolute 100% certainty that the other one is tails. That's kind of what happens with entangled particles. Their properties are perfectly intertwined, no matter the distance.
And here's the real kicker. This connection, this transfer of information, it's instantaneous. It doesn't travel through space from point A to point B. It just is. This seems to shatter the ultimate cosmic speed limit, the speed of light, and it's something that classical physics has absolutely no explanation for.
Now, I know what you're thinking, but this isn't just some wacky theory. For decades, physicists have been running these incredibly precise tests called Bell test experiments. They're designed to see if there's maybe some hidden information, some kind of pre-programming in the particles that could explain this weird connection. And every single time, the results come back and say, nope, it's just pure quantum spookiness. Reality really is non-local.
All right, I hope you're strapped in, because we have officially arrived at the grand finale of weirdness. This is an experiment that seems to violate not just our sense of space, but our sense of time itself.
Say hello to the delayed choice experiment. It's basically a twist on the double-slit experiment, but this twist is a doozy. In this setup, the scientist decides whether to check which path the photon took after the photon should have already passed the slits and committed to being either a particle or a wave. Seriously, let this sink in for a second. A photon travels through the whole setup. It's already past the point of no return. Then, a split second later, the scientist makes a choice. Either look for its path or don't. And if they choose to look, the results show the photon acted like a particle back in the past. But if they choose not to look, the results show it acted like a wave in the past. Which leads to this absolutely profound question. How can a choice we make now affect a path that a particle already took in the past? It seems to suggest that our choice in the present is somehow reaching back in time and defining what past reality was.
It just completely challenges our idea of cause and effect.
So you might be sitting there thinking, okay, this is fascinatingly bizarre, but what does it actually have to do with me? Well, it turns out all this weirdness isn't just some philosophical puzzle. It is the engine driving our future.
That's right, the very same head-scratching principles, superposition, entanglement, the observer effect, are being harnessed right now to build technologies that are going to redefine what's even possible in computing, communication, and so much more.
I mean, we're talking about everything from quantum computers that can solve problems that would take today's best supercomputers billions of years, to totally unhackable communication networks, to sensors with unbelievable precision. Heck, even technology you use every single day, like the flash memory in your phone, relies on a quantum effect. This isn't science fiction anymore. It's the foundation of the next wave of technology.
And that quote really brings it all home, doesn't it? We've gone from a single particle in two places at once to two particles linked by some spooky connection, all the way to a choice in the present defining the past. These experiments force us to accept that reality is, well, it's fuzzy, it's probabilistic, and it's interconnected in ways we're only just starting to wrap our heads around. And so we leave you with this final thought. If the simple act of us measuring something is what collapses a whole wave of possibilities into one single concrete reality, then what does the universe even look like when there's no one around to look at it? Is it just an undefined sea of potential? Definitely something to think about. Thanks for joining me for this explainer.